Welcome to the first part of the introduction section, where we'll explain the organization of and topics presented in this MOOC. This part summarizes the MOOC's structure and contents and outlines the main topics covered in each section of the MOOC. Once we're done summarizing this introduction section, the remainder of this MOOC is organized into 3 sections, which focus on an overview of concurrency in Android and Java, the key Android concurrency frameworks, and concurrency patterns applied in Android software. Material from earlier offerings of the POSA MOOCs are available via the Frequently Asked Questions or fact page, which also explains how this MOOC differs from the previous offerings. We now summarize the contents of the 4 main sections in the MOOC, starting with the introductory material in Section 0. After summarizing the MOOC organization and topics we're covering now, we discuss the MOOC prerequisites and workload so you'll be prepared to complete the MOOC successfully. We then motivate the benefits of concurrency, such as increasing performance, improving responsiveness, and simplifying program structure, and summarize the complexities associated with concurrent programming in Java and Android. Some complexities, such as synchronization and deadlock, are inherent and constitute the rocket science of concurrent programming, which arise from fundamental challenges in the domain. Other complexities are accidental and arise from limitations with tools, techniques, and methods, such as using debuggers that don't detect concurrent programming hazards like race conditions, which can occur when multiple threads simultaneously crash into unprotected data structures and corrupt them. Finally, this section provides an overview of patterns and frameworks, which are highly synergistic tools, techniques, and methods that underlie the material covered in this MOOC. Patterns codify experience and guide design decisions by describing reusable solutions to common problems that arise within particular contexts, such as the domain of concurrent programming in Android. Frameworks reify patterns into reusable software artifacts by integrating sets of components that collaborate to provide a common software architecture for a family of related applications, such as the concurrency frameworks provided by Android. If you're familiar with concurrency, patterns, and frameworks, you can skip over this introductory material, though I still recommend you watch the videos on the MOOC organization, prerequisites, and workload so you'll understand how to succeed in this course. Section 1 presents an overview of concurrency for Android and Java. It begins by exploring Android's layered hardware and software stack, with the goal of helping you become a full-stack developer, with general knowledge of how different layers of Android behave, as well as a specific understanding of how the capabilities at each layer in the Android stack support the concurrency needs of mobile applications and services. This section next describes the Java mechanisms available in Android that applications can use to create, control, and terminate multiple computations that run concurrently within a process. These mechanisms are based on standard Java concurrency features, such as threads and built-in monitor objects that provide synchronized methods and statements. The coverage of Java concurrency mechanisms in Section 1 is intentionally brief, just providing enough information to implement the programming assignments in this MOOC. More comprehensive coverage of Java concurrency is available in online tutorials, articles, and books. Section 2 covers key Android concurrency frameworks. Although the standard Java threading and synchronization mechanisms covered in Section 1 provide the foundation of Android's concurrency infrastructure, these mechanisms can be tedious and error-prone to use in practice. In particular, they don't shield application developers from some of Android's concurrency design constraints, such as its non-thread-safe GUI libraries and its limits on the amount of time the one and only user interface thread can block. To overcome these constraints, therefore, Android provides several concurrency frameworks that allow background threads to run in parallel on multiple cores and communicate in various ways with its user interface thread. Section 2 focuses on 2 Android concurrency frameworks. First, we cover its handlers, runnables, and messages, or Hammer framework, which provides a loosely connected set of classes that allow long-duration operations to run in one or more background threads and then publish the results of these operations to the user interface thread. Second, we cover Android's async task framework, which provides a more tightly connected set of classes that execute long-duration operations in one or more background threads and publishes their results to the user interface thread without manipulating threads, handlers, messages, or runnables explicitly. This section also describes how these frameworks are applied to portions of Android's middleware and packaged applications. Throughout the section, we'll show how Android's concurrency frameworks are enhanced by the application of software patterns that are documented in popular books and websites. The most relevant patterns appear in the pattern-oriented software architecture books, commonly known as the POSA books, and the design patterns, elements of reusable object-oriented software book, commonly known as the Gang of Four book. You may find it useful to refer to the patterns in these books to supplement the discussions in the videos. Sections 1 and 2 outline how various POSA and Gang of Four patterns are applied in Android's concurrency infrastructure and applications developed atop this infrastructure. Section 3 goes further to show how certain of these patterns are applied in concurrent Android frameworks and applications. These frameworks and applications, along with the underlying Java mechanisms upon which they're built, apply many POSA concurrency patterns. We provide in-depth analysis of several key POSA patterns applied in concurrent Android and Java source code, such as the Android Hammer and async task frameworks, as well as the Java util concurrent package available in the Android runtime layer. For example, the monitor object pattern is applied by various synchronized queues in Java util concurrent to coordinate concurrent access to shared state within the queues. The thread-specific storage pattern is applied by the Android Hammer framework to ensure there's only one looper in each thread's event loop. The Hammer framework also applies the command processor pattern to pass runnable commands from one thread to another so they can be processed concurrently. Likewise, this framework also applies a variant of the active object pattern to pass and process multiple requests in multiple threads. Finally, the half-sync, half-async pattern is applied by the Android async task framework to decouple synchronous and asynchronous processing so that one or more background threads can process tasks concurrently and pass the results back to the single user interface thread. Other POSA patterns are covered briefly throughout the lectures in Section 1 and Section 2, as well as in videos available online. None of these patterns are limited to Android, Java, or even mobile device programming, so learning them will help you become a more effective developer for a range of concurrent software applications and infrastructure. Now that we've summarized the organization and contents of the 4 sections in this MOOC, we'll outline how the lectures in the sections are structured uniformly. Each section is composed of multiple parts, which cover a set of related topics, such as Java threads or the Android async task framework. Each part is presented as a single lecture. Some lectures are pre-recorded, whereas others are presented live and recorded for subsequent viewing. Each lecture is composed of segments, which are short video clips that focus on one aspect of a topic, such as starting or stopping Java threads. In-video quizzes periodically pop up to check if you've mastered the material covered in the video. If you download the videos and watch them locally on your computer, however, these quizzes won't appear, but some of the questions may show up on the weekly standalone quizzes, which we'll discuss shortly. In summary, this MOOC covers a wide range of topics, including Java and Android concurrency mechanisms and frameworks, the patterns that guide the design of these mechanisms and frameworks, as well as concurrent applications that apply these mechanisms and frameworks. After watching the lectures, completing the assignments, and participating in the online discussion forums, you should be able to achieve the key MOOC learning objectives, including recognizing the inherent and accidental complexities involved with developing concurrent software on the Android platform, and learning how to apply patterns and frameworks to develop reusable concurrent applications using Java programming language features and Android middleware. You'll also understand how pattern-oriented software architecture and framework techniques can and cannot help alleviate the complexities of developing concurrent software for mobile devices. Finally, if you follow up on the links referenced on the slides, you'll know where to find additional sources of information on how to program concurrent mobile applications and services on Android handheld systems. We analyzed lots of Android software throughout this MOOC. Much of this code comes straight out of the Android open source release, which can be accessed at this link. This link also provides pattern-oriented example applications that demonstrate key Java and Android concurrency mechanisms and frameworks, which we analyze in the lectures to showcase how patterns and frameworks can simplify concurrent application development. You'll need a solid understanding of Java to follow along with the lectures and assignments. If your understanding of Java is incomplete, therefore, it may be helpful to watch the Java tutorials referenced in the FAQ.